This video is about logical positivism and what we can learn about it from Rosenberg's article. Rosenberg begins by reminding us of how Hans Driesch, the 19th and early 20th century biologist, used entelechies to explain some of what he was seeing in embryological development. Hans Driesch was a proponent of vitalism. Vitalism is just the view that life is so unique that it cannot be explained by physical processes. Driesch explained the results of some of the experiments that he was conducting in embryology by using what he called entelechies. What Driesch had noticed was that if you take blastomer cells at a specific stage, when there's 4 cells in the development of a sea urchin embryo, and if you take those 4 cells and divide them into 2, each pair of cells will now go on to develop to be a viable sea urchin. This was quite a surprising result, and Driesch suggested that there was this thing called an entelechy, which was kind of like a life force that existed outside of space and time that was responsible for guiding the development of these cells so that each pair would result in a viable sea urchin. So from Driesch's perspective, an entelechy was a sort of organizing principle that directed embryological development. Now, from the point of view of a logical empiricist or a logical positivist, this is exactly the kind of metaphysical explanation that we want to exclude from science. Because for the logical empiricist, we shouldn't allow our scientific theories to include these vague metaphysical notions that are concepts that really don't correspond to anything that we can measure. So for the logical positivists, the challenge became to find a philosophical way of excluding entities such as entelechies from what counts as good science, but at the same time to include entities such as electrons. And this is not as easy as it might appear at first, because in both cases, in the case of entelechies and in the case of subatomic particles like electrons or alpha particles, we're dealing with entities that we're postulating as invisible realities that explain what we're witnessing in the visible world. And yet some of these postulated entities we want to say are not really scientific somehow, whereas others are. And so the challenge is, how can we tell the difference between the good theoretical entities that we're postulating, in the case of things like electrons or alpha particles, and the sort of bad metaphysical entities that really are not scientific, properly speaking? How can we tell the difference between those two? Well, the logical positivists landed on the solution that we should focus on meaning and the meanings of the terms that appear in our theories. For the logical positivists, only statements whose truth can be confirmed by observations are meaningful. And so Rosenberg tells us a statement is scientifically meaningful, according to a logical positivist, if and only if there's actual or possible empirical evidence that tends to confirm the statement. Now, it turned out that although this was a good attempt to characterize what it is to have a scientific statement, right? A scientific statement is one where we can specify what empirical observations would confirm it. The notion of confirmation is actually kind of vague and difficult to point down because it's not clear what is to count as empirical evidence for a given statement. So specifically, you could say, well, wait a minute, we have empirical evidence that entelechies exist because every time we take these blastomeres at the 4-cell stage and divide them into pairs of 2, we really do see that the embryological development is guided to lead to 2 separate, distinct, viable organisms. What better evidence, empirical evidence, could you want that entelechies are real? And that sounds like an argument that's very similar to what you would say if you were trying to argue that electrons are real. And so this attempt to focus on meaning was one that seemed hopeful, but it wasn't immediately obvious that it was going to do the job that it should do. Though, as we'll see in later attempts to refine and revise and improve logical positivism, this general view that the meaning of a statement is just the method in which you confirm it or verify it became very, very influential. So there are some general claims or tenets that all logical positivists tended to agree on. The first one, and this is a very famous one that they're sort of nowadays almost ridiculed for, is that metaphysics is not knowledge. One way to understand logical positivism is to think of it as grounded in a deeply Socratic concern, which is to avoid the illusion of wisdom and knowledge. What the logical positivists were concerned with was that a lot of metaphysical speculation was getting passed off as science when in fact it wasn't scientific knowledge. And so they wanted to find a way to say, no, look, that whatever you're doing when you're making these speculations about these entities like entelechies that are outside of space and time, but nevertheless act into space and time, whatever you're doing, that cannot count as knowledge. They also shared views about the relationship between mathematics and empirical knowledge. So, for example, they all believe that mathematical claims are necessary truths, but they are vacuous. This is an interesting and unique view about mathematical knowledge, which says that mathematics is not really about anything at all. It is empty of content. In contrast to that, scientific knowledge is full of content, but its claims are never necessary truths. They are what we would call contingent truths. And finally, a really important part of logical positivism that was shared by all logical positivists was that philosophy itself became sort of redefined. Instead of being an activity of searching for wisdom or deep truths about the world, philosophy became redefined as an activity devoted to clarifying meaning. And that became a deeply influential feature of logical positivism that to this day continues to influence especially Anglo-American English language philosophy.